All right, so for the final topic of this unit, we're going to be applying our knowledge from linear equations to solve real-world problems. So in the following examples, for part A, we're going to have to generate a linear equation or expression based on that problem that represents the given problem. And then for part B, we're going to actually have to solve the linear equation so that way we can find the answer that's being asked to the question. So for example 1, we're given a taxi company charges a flat fee of $4 plus $2.50 per mile. If a passenger bill comes to $29, how many miles did the passenger travel? So when doing these kind of problems, the first thing you want to ask yourself is, what variable do we want, and what does that variable mean? So I'm going to be very typical here and say we're going to do the variable x. And I encourage you to pause the video if you need to think about what would the variable x potentially mean in this case, or in this specific problem. And in this specific problem, x means the amount of miles, or x means miles. So if we want to set up a linear equation where x is miles, let's read through this one more time. So a taxi company charges a flat fee of $4. So we know for sure, regardless of how much we travel, we automatically are spending $4. So I'm going to write that here because we know regardless that 4 is going to be there. Plus $2.50 per mile. So it literally says plus here. So I'm going to write plus $2.50. And then per mile means times x. Because every mile we are in the taxi, that x is being multiplied by 250. It's 250 per mile. So for 2 miles, it's 250 times 2. 3 miles, 250 times 3. But in this case, we know that the total comes to $29. So this whole equation has to be equal to $29. And that's your linear equation for this specific problem. And now let's solve for x and see how many miles this person traveled in the taxi. So I'm going to bring that equation down here. 4 plus 250, x equals 29. And let's solve for x. So I'm going to first start by subtracting 4 on both sides. So we get 250. We get 250x equals 29 minus 4 is 25. And then we're going to have to divide 250 on both sides. And when we do that, we get x equals 10. And 10 what specifically? 10 miles. Because that's what we said. That's what we had said in the beginning, that x represents miles. So this person traveled 10 miles by taxi. All right. Example number 2, I encourage you to pause the video and try this problem on your own, both parts A and B. And assuming you have given it a go, let's work through it. So we have Ella is saving $12 each week to buy a new skateboard. If the skateboard costs $132, how many weeks will it take for her to save enough? Well, so let's say x represents the amount of weeks. So x represents weeks. We know that Ella is saving $12 per week. So we're going to have 12 times x. But we want to know specifically how long it's going to take if the skateboard costs $132. So we have to set this expression 12x equal to 132. Because we want to know specifically when will 12x equal 132. So that's our linear equation. Let's solve for x. So to solve for x, we're going to divide both sides by 12. And 132 divided by 12 is 11. So we get x equals 11 weeks. So that's our final answer. It will take Ella 11 weeks if she saves $12 per week. Alrighty. For example, number 3, we are given the sum of 3 consecutive integers is 75. What are the 3 integers? Now this problem is a little bit different, so let's look at some vocab. So recall from the first unit, we know that sum means addition. We're given 3 integers, but what does consecutive mean? Consecutive means that numbers are directly after each other, so it goes up by a count of 1. So 3 consecutive integers, for example, could be 1, 2, and 3. Or we could also have 3 consecutive integers that are 72, 73, and 74. Now notice, consecutive integers go up by 1, a value 1 each time. So if we want to represent this algebraically, let's say x represents the first consecutive integer, for example, 1. So our second consecutive integer would go up by a value of 1, so we're going to do x plus 1. And then our third consecutive integer goes up by a value of 2, so we're going to do x plus 2. So this here represents our 3 consecutive integers algebraically. So we're going to write, for our linear equation, we're going to write x, our first one, plus x plus 1, our second consecutive integer, and then we're going to do plus x plus 2, our third consecutive integer. I didn't leave a lot of space here. My apologies. I'm going to erase this here. And then we're given in this specific problem, though, that the 3 consecutive integers is 75. So that means it's equal to 75. So that's our linear equation. Now let's solve for x. So we have x plus x plus 1 plus x plus 2 equals 75. Now notice I just dropped those parentheses because we don't really need them, because nothing's actually being distributed into these parentheses. It's just an addition sign. I just wrote those parentheses so we can see, so it's more clear where I got that from those numbers from before. But now let's combine like terms. So we have 3 x's and we have a 1 and a 2. So I'm going to combine the 3x, x plus x plus x, that's 3x. And then we have 1 plus 2, which is 3. That's equal to 75. Solving for x, I'm going to subtract 3 on both sides, and we get 3x equals 72. To solve for x, I'm going to divide by 3 on both sides. 72 divided by 3 equals 24. Is this our answer? Are we done? We aren't done, because look, we want to know what the 3 consecutive integers are. And recall from the beginning, I defined x as the first consecutive integer. So since this is the first consecutive integer, we need the other 2. Now recall the other 2 go up by a value of 1. Well, the first consecutive integer goes up by a value of 1. And the second one goes up by a value 2. So here, our second consecutive integer is going to be 25, because it goes up by a value of 1. And then our third is going to go up by a value of 1 from 25, or up by a value 2 from 24. So the third one's going to be 26. And those are your consecutive integers. Now, in example 4, we have Sam is 5 years older than his sister. In 7 years, Sam will be twice his sister's age. How old is Sam now? So we have a little bit going on here. So let's take it one step at a time. So we first want to know, how old is Sam now? That's the question. That's what we want to know. So I'm just going to box that here. Okay. So we know the question is, how old is Sam now? So let's next start off by defining what the variable x is, or what the variable x means. So I'm going to say the variable x is Sam's age. Oops, not same. Sam's age. The variable is Sam's age right now. So I'm going to take this one step at a time. Let's define expressions as they are now. So Sam, as we said, his age is X. But what about his sister? How old is his sister right now? Well, in the problem, we're told that Sam is 5 years older than his sister. So his sister is 5 years less than Sam. And then let's take a look here. We're also given some more information that in 7 years, so in 7 years, we're given that Sam will be twice his sister's age. So before we add in that Sam will be twice his sister's age, let's just translate these algebraic expressions from now to 7 years. And to do that, we're just going to, Sam's expression, it's just going to change by a factor of 7. So we're just going to say x plus 7. And then for his sister, we also just add 7 years. So, I don't know, sister. For a sister, we're going to do x minus 5, and then we're going to add 7 to it, because this is 7 years into the future. So this whole expression changes to negative 5 plus 7 is 2. So we're going to get x plus 2. Now, the last step we want to do is we're going to have to translate twice as old. Into math, or mathematical algebraic expressions. So we know that Sam's future age in 7 years from now will be twice his sister's age. So what I'm going to do is we're going to say Sam's age is equal to 2 times his sister, or her sister. Okay, or his sister, yes. So Sam's age is 2 times his sister, and we defined that Sam is x plus 7. So we're going to write x plus 7 because that's Sam's age. And then we're going to say 2 times his sister, which is x plus 2. So this is our algebraic expression. We have x plus 7 equals 2 times x plus 2. Now that we have the expression, all we have to do is solve for x, and that's Sam's age right now, because as we defined earlier, x is Sam's current age. So all we have to do now is solve for x. So I'm going to do that down here. So I'm going to distribute in this 2. So that'll get us x plus 7 equals 2x plus 4. And then now I'm going to subtract x on both sides. So we're going to get 7 equals x plus 4. And then I'm going to subtract 4 on both sides. And we get x equals 3. So that means Sam is 3 years old currently. And that's our expression. This problem here, example number 4, is a little bit challenging, and you won't see problems this you won't see problems this confusing on the homework or the test, but it is good to have more challenging problems. For number 5, we have if James runs at the steady pace of 6 miles per hour, how long will it take him to run 15 miles? What do we want to know? We want to know how long, the time. How long exactly will it take him to run 15 miles? So, if you aren't aware, there is a formula where you can find that tells you how long somebody's traveled if you multiply the rate and how long this rate or how long something or someone was going for at the specific rate. That tells you the distance. But because we want to know the time, we can substitute time in for x. So let's do that. So we know that James runs at a steady pace of 6 miles per hour. So we're going to do 6, and then we want to know what x is. So 6 miles per hour is our rate. We want to know what x is, so rate times time. We're going to set that equal to our distance, which is specifically 15 miles. And that's our linear equation, 6x equals 15. So now, all we have to do is solve for x. So we're going to divide by 6. We get x equals 15 sixths. Now, if we use that, if we convert that to decimal form, 15 divided by 6 equals 2.5. So x equals 2.5 hours. So that means it'll take James approximately 2.5 hours to run 15 miles at a steady pace of 6 miles per hour.